Hello, I'm Steve North, and the title of my presentation today is Umamimi Robotic Horses Using Configurable Code Profiles to Replicate Individuality in Equine Animatronics. In this work, I developed a set of prototype programmable animatronic robotic horses. At a basic level, Umamimi is inspired by the machines developed for animatronics and puppetry. Think of Michael Morpurgo's Warhorse, for example. So in some senses, this is just a maker or prototyping project. My starting point was, has anyone actually done this before? Have they built a set of responsive robotic horses? And it appears that they haven't. For me, that is sufficient justification to take on the project. Of course, the Umamimi robotic horses are a prototype device. They're not intended for significant quantitative evaluation, at least not at this stage. Beyond the practical applications, there is a more esoteric autoethnographic element to this research, allowing the author to explore what it means to be a horse-human assemblage, and I've started to explore this in other conference and journal publications. So the possible longer-term applications for this might be, and there are many, when worn by a human to explore interaction between horses and humans using technologically enhanced body language, and when used standalone as a potential robotic companion for solo, stressed or recuperating horses. In the short paper presented here, I've focused on one aspect of this project, which I would suggest is a contribution to knowledge in the ACI field. That is, using ethological observation of physical movement characteristics in an individual real-life non-human and translating these into corresponding movements in a robot which is itself simulating physical aspects of the same species. So I've made baby steps to explore this by proposing a workflow for modelling the personalities and moods of real individual horses using an ethogram for logging horse ear movement characteristics. The workflow journeys from simple observation and logging of ear movements in an individual horse through to creating configurable code profile files that may be loaded by Umamimi, completely transforming elements of the ear movements. Just to explain, the robotic ears have 1. User trigger movements when worn by a human, and 2. Random movements when there's no user input and the device itself is static and level. So this work suggests possibilities for studying a horse's response to experiencing her own ear movement characteristics reflected back at her via technology. The Umamimi hardware is built on a metal framework with black faux fur covering 2 microservo motors. Each of them move an ear independently in incremental steps through a maximum range of 180 degrees. At the heart of the device is an all-in-one electronics project board. This board is powered by a programmable processor. The software for Umamimi was developed using the Arduino programming language, which is a set of C and C++ functions. Umamimi responds to detected changes in an accelerometer, similar to the one in a smartphone, when a user moves their head. The default position for the Umamimi's ears is neutral. Beyond this, in response to changes in the user's head orientation, Umamimi has 4 predefined movements. These are fully forward, fully back, 1 ear turned to the left and 1 ear turned to the right. So, what happens when there's no input from the wearer? Well, this might be considered to be the device's default behavior when idling and waiting for instructions, waiting for user input. Configurable code profiles have been developed, allowing the device to perform random micro movements during this default behavior period. These can be used to model the characteristics of different horses or horse emotional states generally across the species. Unfortunately, describing this in a lot of detail is beyond the scope of this presentation, but we will get into a little bit more of the detail. So at the moment, I'm just running with an ear profile which when making random micro moves doesn't move that much. But I'm just going to show you how the user triggered moves work. So if I tip my head slightly to the right, the ear should track right and stay there until I bring my head back up again. So that's the accelerometer is reading my head position. I have to some extent get a feel for where the level position is. So that's the left position, should be. Then there's the more dramatic full ears back, which is a bit like the kind of horse pinning in anger or fear.
and then there's a slight forward tip of the head which brings the ears forward into a kind of full attention position. So I'll show you again, right ear, left ear, right ear, left ear, ears back, tension place, and then back to neutral. Okay.
In order to collect data about real horses, I developed a very simple ethogram for observing the horse ear movement characteristics that are indicative of arousal or vigilance level, mood, and personality. Of course, this might also be applied at a later stage to the robotic ears themselves. In the proposed workflow, actual observations of live horses will be conducted on video clips using logging. After configuration, each behavior from the ethogram appears as a clickable button on the interface. See the lower part of the left sidebar in the slide image. After completion of a logging session, the results are saved in a CSV, comma-separated value file. So in this slide, we're seeing an actual file, configuration file, profile file. Here are the three code values. As calculated from the data collected in the ethogram, a detailed description of the calculation process to get from the data is beyond the scope of this presentation. But in a previous slide, we saw the actual logging process going on, clicking on the buttons while watching the video. The CSV file that was generated by that goes through some calculations and formula in order to generate these three values that are supposed to be representative of the individual horse or the mood state. The file is actually a plain text file implemented as a C++ header file. To change Umamimi's behavior, the code for Umamimi is recompiled and uploaded to the onboard microprocessor on the ears via a USB cable, and this only takes a few seconds. So in terms of potential further work on the code profiles, which is the focus of this, there is obvious potential for a broader Umamimi ethological or quantitative study featuring multiple horses, observations, and logging using the ethogram. You would perhaps apply the ethogram to multiple living horses, apply the ethogram to Umamimi operating with code profiles based on the data produced from those living horses. And then we ask questions such as, are there similarities between the living horse and its modelled ear characteristics as represented in the observational data? Issues of observer bias would need to be accounted for. Both intra and inter observer reliability could be tested, and the use of expert calibrating or consensus observers might be applied. There are also other areas where general work could be done to expand this further. For example, it would be a good idea to video the interactions between humans wearing the robotic ears and the horses, and try to capture interesting horse-human vignettes on video for discussion and qualitative analysis. And it's interesting to see how there are methodologies here that are both qualitative and quantitative and descriptive in terms of the building the device. For the humans reflecting, writing on the experience of interacting through body language and tempering being part of the horse herd. This is the horse-human assemblage stuff, which I'm covering in other papers with quite different themes and feels. There is also, as indicated earlier, the possibility of looking into Umamimi's potential as a robotic companion for solo stressed or recuperating horses. This is instead of the physical mirror that's previously been discussed in literature, particularly in equitation science, about how horses might be comforted by a reflection of themselves. And finally, here's just a nice photo of me, uneared, wearing the Umamimi robotic horse ears. On the left is my American Quarter Horse Free, and on the right is my Dale's Pony Duke. And this was one of the informal sessions that I conducted with them when I was evaluating the ears and testing different bits of functionality. So we've reached the end of my presentation. Thank you very much for listening.